Perceptually motivated temporal upsampling for high refresh rate displays. This 60 Hz video only gives a didactical preview of stimuli to be perceived at 120 Hz. Small spike artifacts are visible, which are blurred and invisible at 120 Hz. Please watch this video using a fast CPU, disk drive and display to guarantee playback at least at 60 Hz, and please refer to the supplemental binary to experience the true effect. The human visual system tracks objects in the real world as well as on a display using smooth pursued eye motion. Current displays present discrete images for an extended period of time, while the eye is tracking an illusion of continuous motion. If the refresh rate becomes low, this leads to an averaging in space instead of tracking in time, called hold-type blur. We propose an upsampling scheme to compensate hold-type blur by extrapolating a high refresh rate stream from a rendered low refresh rate stream in real time. Our operator outperforms image-based techniques as used in current commercial high refresh rate displays. Note the pumping effect when filmed using a high-speed camera. We compare our result to ground true high refresh rate sequences, here sponsor at 60 Hz and here at 20 Hz. Notice the blur and jagginess, and notice as our upsampling removes this blur. Our technique starts with a warping that respects motion discontinuities. We first snap vertices to discontinuities and then warp those snapped vertices according to motion flow. When warping, we also use depth information to resolve pixels where multiple grid cells map. At 120 Hz, remaining artifacts can be suppressed by blurring, as blurred in-between frames are not perceived at 120 Hz or more. Here, we captured the result of our operator on a 120 Hz display using a high-speed camera. We conducted a user study that compares 120 and 40 Hz and our upsampling using different stimuli. In this tree scene, a lot of occlusion and disocclusions appear, which are difficult to handle image-based. Also, fine geometric details, as in this architectural model, can be reproduced. For motion that is perfectly tracked with the eye, such as this fan, our method is very similar to ground truth. At the same time, motion which is not tracked by the eye, such as this running camel, our method falls back to low refresh rate without introducing new artifacts. Finally, we tested our operator in a game scenario. Using our upsampling, task performance is much more similar to high refresh rate than to a low refresh rate, but using only a third of the compute power.